If we want to solve the differential equation, it's second order because we've got the second derivative going on. We've got constant coefficients. A is 1, B is 2, C is equal to -3. And we've also got some initial conditions here. So we're going to use those to calculate our values of A and B when we get further down. So using the template for solving this type of differential equation, we let y equals e to the kx, and we find y dash and y double dash and substitute back in. So y dash, derivative, we've got to find the derivative of the power. The derivative of the power is k, and that goes at the front. E to the kx, bit of chain rule going on there. And then the second derivative, we've got to find the derivative of what's up there. So that's k, comes out there, multiply by that k, we get k squared, e to the kx. Okay, so the second step is to sub in for y dash, y double dash back into the original equation. It's homogeneous here, so it's equal to 0. So we get, instead of y double dash, we can put k squared e to the kx plus 2. And y dash is k e to the kx minus 3 e to the kx is equal to 0. Step 3 is to divide right through by e to the kx, and we get k squared plus 2k minus 3 is equal to 0. We know that e to the kx cannot be equal to 0. Okay, so we now got to use a quadratic formula to find k. So we've got, so my a is equal to 1, b is equal to 2, c is equal to -3. Sometimes it helps to write those down. Quote the quadratic formula, k equals minus b plus minus square root b squared minus 4ac all over 2a is equal to minus b, which is -2, plus or minus square root b squared is 4 minus 4ac. 4 times 1 times -3 is -12 all over 2 equals -2 plus or minus 4 plus, that's minus minus a plus, 4 plus 12, 16, square root of 16 is equal to 4 all over 2 equals -2 minus 4, we'll take the minus first, all over 2, or -2 plus 4 all over 2, and that's equal to -6 over 2 is -3, negative plus, would be +2 or +1, -3 or 1. Now, alternatively, you could have used factorisation up here. If you could spend a bit of time though looking at something and thinking, oh, that definitely will factorise, then it won't factorise. Whereas a quadratic formula, you can go straight for it, and there are 3 scenarios for solving for k here, so this is the easier one. So quadratic formula will always work here in this situation. Alright, so that'll allow us then to state our solution as, so for y equals a, e, now to the k1, so we'll make this one k1, this k2, does not matter which one you make k1 or k2, so ae to the minus 3x plus be to the k2x, k2 is 1, so 1x, which is just equal to 1. Okay, now that's the general solution. We've got to go back and see, I think I recall up the top here, yes, we've got initial conditions. We've got, when we put x equals 0, you get a value of -4 in the for y, and then y dash, when you put x equals 0, y dash is equal to 4. So if we go y of 0 equals -4. So when we put, so that means -4 when we put x equals 0. So a e to the 3 times 0 is 0, so either 0 is equal to 1 plus b. So we've got -4 equals a plus b, that's equation 1. And we also know that y dash of 0 is equal to +4. Now y dash is equal to -3 a e, so we're doing the derivative up here, so you've got to find the derivative of that is -3 a e to -3x, and then plus the derivative of b e to the x. The derivative of x is equal to 1, so that'll be just plus b e to the x. But you know y dash of 0 is equal to 4, so we've got 4 equals -3a, 0 in up there, e to the power of 0 is 1, so -3a plus, now b e to the x will be just equal to b, because e to the power of 0 is equal to 1. So here is equation 2. Okay, we want to do, there's two ways to solving these simultaneous equations. You've got elimination or substitution. Substitution, I could rearrange this and make a the subject, so take the b over there. Well, why don't we do that? Okay, so from this one here, if I want to make, it doesn't matter which one, let's make b the subject. I'll take a over there, so we get -4 minus a is equal to b. So when I come down to here, instead of this b down here, I can write -4 minus a. So I'll go sub for b, and I get 4 equals -3a. Now instead of that b, I'm going to use -4, so that'll be plus -4 minus a. Okay, so removing the brackets, we get -3a minus 4 minus a. Take the -4 over the other side and become +4. 4 plus 4 is 8. -3a minus another a is -4a. And divide both sides by -4 and you get a equals -2. And then we can actually find b. So sub for a. I'm going to call this up here 1a and 1a, and you get -4, and minus a will be -2 is equal to b. -4, minus and minus become a plus, so there'll be -4 plus 2. -4 plus 2 is -4, so b is equal to -2 as well. So now we can state our solution up here, and we get y equals, instead of that a up here, we've got -2 e to the -3x. And so that b up there, we've also got -2, so that's -2 e to the x. And there is our solution to that differential equation. So just go back up the template. Differential equations of this form, we try y equals e to the kx, and then we try and determine the value for k. So in order to be able to substitute back in there, we've got y equals e to the kx, find the first derivative, the second derivative, substitute in, divide right through by e to the kx because it's unequal to 0, we get a quadratic. Whichever way you want to solve, you've got solving by factorisation, or you've got by using the quadratic formula. The quadratic formula here will work out to get values of k1 and k2, and we substitute in y equals ae to the minus 3x plus be to the x. We have initial conditions, which allows us to work out values for a and b, which we go through and work out, and then finally we quote our answer.